the third activity is to improve the emotional and cultural level of interaction with computer. So the interaction itself and also involves probably different culture and different background, that your interaction may also be different. How do we address this to make it make the user more engaged and more pleasing, right? So now quickly into the few topics: motivation and terminology, and then 3 dimensions of painting. And I think you all know better than I do, like a form, color, and texture. Those are 3 dimensions, not in the traditional computer science sense, 2-dimensional, 3-dimensional, right? And this is in art sense. And visual cognition, and how do we make use of the visual cognition in information visualization design. And here, composition. Of course, that's very important in a given 2D space. And so the motivation is that we want to benefit and enrich information visualization from the well-established theory and techniques in abstract painting, because that's much older than computing. Computing has been around for maybe 60 years, right? So, but art has existed for 1 centuries. So why can't we learn from the art and from the art, and specifically about abstract painting? And in the spirit of aesthetic computing, and this is a concept that could establish a new discipline on the convergence of art, science, and technology. So this is exactly what we are doing in this school. And so this is from Paul Fishwick's book. So now you will see that I use a different color coding here, that I will color code the computing-related concepts in blue, and art and design-related concepts in red, and the generic concepts in black. So now we talk about what is information visualization. It's a pretty long definition, but we just focus on a couple of keywords like abstract, and no natural and obvious physical representation. So this is the definition for information visualization, which is different from scientific visualization. You can see, in contrast to scientific visualization, which focuses on data, and but information visualization focuses on information, which is often abstract. So that's why I mentioned earlier, scientific visualization visualize the artifacts that we actually know and they exist in the real world. But information visualization visualize mostly the abstract objects. And I will show you some examples. So now, this is a definition of abstract painting based on Kandinsky. And we can see the Kandinsky as the basically the pioneer or founder of abstract painting. And again, he has a pretty long definition, and but basically just to say that use the color and the shapes without recognizable objects. And but you see, usually pure, non-objective, and most commonly abstract. So this is abstract painting. So now let's look at the similarities of the 2 areas, abstract art and infobase. They are both abstract and non-representational, right? So they have the common characteristic. Then, since we find they are common, and then we should be able to borrow from each other's techniques and successful theory and techniques. Now, 3 dimensions. The first one is a form. This I extracted this knowledge. I learned this all from Kandinsky's theoretical books. I read twice of his first book, which is called Point, Line to Plan. I think he talks about the compositions and the forms and so on. And he has another book called On the Spiritual of Art. I think that he talks about color, how to use color. Very hard to read, translated from German to English. So I based a lot of this on his on Kandinsky books. So basically, they consist of points, lines, and plans. Okay, and plans also include contours and shapes, from 1 dimension to 3 dimension. This time we talk about the dimensions. Okay, the space. And in visualization or in computing in general, the visual formalism, we typically we use them to convey information, such as diagrams, charts, and maps, consist of points, lines, and plans, in a very similar fashion. Okay. And then the first form is a point. So this is according to Kandinsky. The point digs itself into plan and asserts itself for all time. Thus, it presents the briefest, constant, innermost assertion. And briefly, we all know that in any kind of painting software, we also use a point, to give it color and shape and size to convey different information. This is used in information visualization as well. And line, there are 3 types. Again, according to Kandinsky, horizontal, vertical, and diagonal. And horizontal, he actually does give certain semantics or meaning to different lines. Like horizontal lines, he said cold and temperature cold, and flat and support on which people can stand and move. Okay, and vertical is like infinite and warm possibility of movement. Diagonal is basically in between. And we, in information visualization, we use line styles, dotted, dashed, patterned. Okay, we could also simulate the paint brushes, okay, with the brush stroke as well. And we also have use an edge and a solid object and connecting these edges to make a graph or a trending kind of diagram. And these are all successfully used in statistical charts. And interestingly, these several forms of lines basically defined by Kandinsky, like straight lines, basically a pool, use a force, okay? And these angled lines are formed like that. And force has been used to define lines, and you will see that in graph drawing, we also use force to define. And the third one, I will show you that in the context of a plan, how to draw the graph using force. And the plan, the third form, is determined by the location, size, shape. A plan can play a key role in composition and empowers color and texture for rendering unlimited image effects. So that is in art, basically. You can paint whatever, a creative image there. And the shapes can imply orientation. This is a very important, I think, in art, but in information visualization, I think that people have not really made use of this guideline. And the symmetrical shapes, such as circles and squares, they suggest stability. So later I will also show that I think in art as well, they actually do give you aesthetic feeling. So a straight line in the plan, according to Kandinsky, he said is a form that approaches the edge of the plan and its tension increases until at the moment of contact with the border, like this one, the tension suddenly disappears. You see, this is like a, has a tension, but this one doesn't have any tension anymore. Very interesting, because in graph drawing, that's exactly what I have experimented. Like drawing this graph, node edge diagram, and we also call graph. And we draw this, but to stretch it, and invented by Peter Eads in Australia a long time ago, called the spring algorithm, or force-directed algorithm. That means we treat those as particles, but all this as springs. And the springs, they could actually propel and attract each other. So if they are connected, they would actually attract. And but if they are not, they would propel each other. So that will stretch the nodes apart and draw it very, very nicely. So avoid edge crossing very well. So if it is a planar graph, it will be automatically drawn without edge overlapping. So edge crossing. So this is very nice. And also I experimented as well that if I draw a boundary around this, and I can let this animate and move around because you can pull it. And as soon as part of the graph touches the boundary, the force terminates. It will stop moving. Very interesting. So this is exactly what Kandinsky has defined about this line that touches the boundary. And it's almost the same phenomenon. Okay, I experimented that as well, and because this is animated when you draw this graph, can be animated very well. So this is what we did using that the same algorithm. We improved that algorithm a little bit, and this is to we want to show the relationship between buyer-seller relationships on eBay. So we actually obtained the data from eBay, and this is a seller, and these are the buyers from this same seller. And but this seller is also buyer of this person, and so on. So we draw this as a kind of a diagram, and we improved this algorithm by sort of try to pull the nodes apart, but still there's some overlap. But this is a little bit old algorithm we did. And the third form, second form, sorry, is color. And that's why I use a background with the color. That's why, because we have the white color as well. The most essential idea carriers for abstract pen artists basically is color, and color is heavily used. For psychological impact, for example, purple to convey horror, and pink for joy, and green for envy. But of course, for different culture and even different time now, the different color may actually refer to different meanings, right? But this is according to Kandinsky at that time. And also, black refers to the symbol of death, and white color of birth. I think the Chinese culture may be the opposite. So that's also different for different cultures. And to use color in information visualization, of course, that's very common and also very successful. Like in encoding additional attributes of data in high-dimensional visualization, we want to utilize humans' color perception. So use color coding to render different information. So for example, this is one of the earlier papers published in information visualization. Basically, this just displays 8 different dimensions of data. Each block is one dimension, represent one dimension, but just 2 different types of representations. This is called the spiral. Basically, this is one dimension. One dimension is basically you have just one very long line, a lot of values on that. So it just circle around, make it a spiral. But this is to make it kind of four quadrants that you can actually represent later. But the first, this first simply is an index to tell the people what is my arrangement here in these 8 dimensions. That's all. But the reason here, I don't need to explain the details. But the reason I want to show this is that this kind of visualization using this color coding is ugly, right? And I don't think it's aesthetic. And then if I show you something similar to this, and you think that's better. So, right? And Kandinsky has already had this painting. And why don't we simply color code it this way? And also introduce certain randomness. So maybe more aesthetic.